Hello everyone, I am Ritika Suskar, Assistant Professor IT Department. So in the course of machine learning, we started our second unit. Okay, so second unit is based on regression. So in the previous lecture, we discussed about the overfitting and underfitting in machine learning. Okay, so in this lecture, we discuss about regularization and its technique. So in that, in the machine learning, the one of the major aspect of training our machine learning model is avoiding the overfitting. So the model will have a low accuracy if it is a overfitting. Okay, so this happens because our model is trying too hard to capture the noise in our training data set. Okay, so in the previous lecture, as I said, the overfitting is what if in the model, in the given model, there are different noises are present. Okay, so the machine cannot capture this noise data. Okay, so that the performance becomes low. The machine learning model, the performance becomes low by using these overfitting techniques. To reduce this overfitting, there are different techniques are used. Like regularization method is one of the important aspect in reducing the overfitting. Then increase the feature selection, then increase the complexity of the model so that we can reduce the overfitting. Okay, so in the overfitting there are some issues are present in the performance model. So to reduce this overfitting we can use the regularization technique. So this happens because our model is trying too hard to capture the noise in our training data set. So by using this noise, we mean the data points that do not really represent the true properties of our data, but random changes. So learning such data points make our model more flexible at the risk of overfitting. So the concept of balancing the biases and the variance is helpful in understanding the phenomena of overfitting. So here in this lecture we focuses on the techniques that helps to in avoiding and also increasing the model performance. So here the technique is a regularization technique. So this is the form of a regression that constant or regularizes or string the coefficient estimates towards zero. See, in other words, this techniques discourages the learning a more complex or flexible model so as to avoid the risk of overfitting. So what is the regularization? Regularization consists of different techniques and methods used to address the issues of overfitting by reducing the generalization error without affecting the training error much. Okay. So choosing overly complex models for the training data points, it can often lead to the overfitting. So on the other hand, the simpler model leads to underfitting the data. So hence the choosing just right amount of complexity in the model, it is a critical. So there is a complexity of model. It cannot be directly inferred from the available training data. So it is often impossible to stumble upon the right model complexity for a training. So this is where the regularization comes into the play, making the complex model prone to the overfitting. So yeah, the regularization is what it is the one of the important aspect of the machine learning. It is a technique to prevent the model from overfitting by adding the extra information data. So sometimes the machine learning model perform well with the training data but does not perform well with the test data. Okay, as I said in the previous lecture, overfitting means what? Some machine learning models perform well with training data but cannot perform well with the test data. Okay, it means the model is not able to predict the output when it deals with some unseen data by introducing the noise in the output, and hence the model is called as the overfitting model. So this problem can deal with the help of a regularization technique. So to overcome these issues of overfitting, we can use the regularization technique. Okay. So this regularization is used, it can be used in such a way that it will allow to maintain all the variables or features in the model by reducing the magnitude of the variables. Okay, so it means accuracy as well as the generalization of the model. So this technique is mainly regularizes or reduce the coefficient of the features towards zero, and in a simple word, in the regularization technique, we can reduce the magnitude of the feature by keeping the same number of features. Okay. So why the regularization required? The regularization is often used as a solution to the overfitting the problem in the machine learning. So the common causes of for overfittings are, the first one is when the model is complex enough that it starts modeling the noise in the training data. Okay, why we use the regularization? If your model is a complex model where we have some noise in the training data. So in that case, we use the regularization. And the second one is when the training data is relatively small. Okay, our training data is relatively small and it is a insufficient representation of the underlying distribution that it is a sample from. The model fails to learn a generalized mapping. Okay. So these are the two reasons for that we can use the regularization. Okay. So here we have a original distribution, then regression to the complex model and insufficient training data. So we have some model but we are having the insufficient training data like this. Okay. For the complex model, the regression is like this in the second diagram and the original distribution कैसा होगा इसका like this. Okay. So the regularization is what? It helps to overcome the issues of overfitting. So next is how does the regularization method works? So regularization works by adding the penalty or complexity term to the complex model. Okay. So let us consider simple linear regression equation y equal to b0 plus b1 x1. Okay, so this is also called as the beta 0, beta 1 x1, b2 x2, b3 x3 and so on up to the bn xn plus b. Okay, normal linear equation कैसा था? Y equal to mx plus c. Okay, or we can call it a0 x plus a1 या फिर b0 x plus b1. Okay, but if you are having number of terms, so in that case the equation like y equal to b0 b1 b2 b3 up to the n number of data set plus b. So in this above equation y represent the value to be predicted. Okay, so and the x1 x2 xn are the features for a y. And what is the B0, B1, Bn? Are the weights or some magnitude attached to the features respectively. Okay. So here it represents the biases of the model and B represent the intercept. Okay. B is what over intercept, Y intercept. So linear regression model try to optimize the B0 and B to minimize the cost function. B0 is used for linear regression model try to optimizes and B is what minimize the cost function. So the equation for the cost function for the linear model is what? So here the summation of I equal to 1 to m. So here yi is what our actual value and yi dash is what our predicted values. Okay. Brackets 12 is equal to summation of I equal to 1 to m yi minus summation of j equal to 0 to n bj into xij per whole bracket square. Okay. So now we will add a loss function and optimize the parameter to make the model that can predict the accurate of y. So the loss function for the linear regression is called as a residual sum of squares. Okay. So here we can use the loss function. We already discussed in previous lecture in the gradient descent algorithm what is meant by loss function and the equation for the loss function. Okay. So here we can add some loss function and optimize the parameters to make the model or to make the model that can predict the accurate value of y. Okay. So next is the techniques of regularization. So the two commonly main regularization techniques are L1 and L2 regularization. A regression model that uses the L1 regularization technique is called as a lasso regression, and the model which uses the L2 regularization is called as a ridge regression. Okay. So there are mainly two regularization techniques, which are first is the ridge regression and the second one is a lasso regression. Okay. So here the first regression is regularization technique is a ridge regression. Okay, so ridge regression is one of the types of linear regression in which a small amount of biases is introduced so that we can get a better long-term prediction. Okay, in the ridge regression we are adding some small amount of biases. For that we can get the proper prediction value. Okay, to get the proper prediction, better prediction. So ridge regression is a regularization technique which is used to reduce the complexity of the model so that it is called as a L2 regularization. Okay, ridge regression is called as a L2 regularization technique. Okay, so in this technique the cost function is already by adding the penalty term to it, and the amount of bias is added to the model is called as a ridge regression penalty, and we can calculate it by multiplying with the lambda to the squared weight of each individual features. So the equation for the cost function is ridge regression is what? Okay, like this. यहाँ पे हमने already discuss किया है. Okay, but if we are using the ridge regression, so here we are adding some lambda. Lambda is what here? Lambda tends to the 0. Okay, so this is the regression penalty, and the summation of j equal to 0 to a b j square. Okay, so in this equation the penalty term regularizes the coefficient of the model, and hence the ridge regression reduces the amplitude of the coefficient that decreases the complexity of the model. So as we can see from this equation, the value of lambda tends to 0. The equation becomes the cost function of the linear regression model. So for the minimum value of lambda, the model will resemble the linear regression model. So in the general linear or in the polynomial regression, we fail if there is a high collinearity between the independent variables. So to solve such problems, okay, so ridge regression can be used. So if you are having the high collinearity between the independent variable, so in that case we use the ridge regression technique. So ridge regression helps to solve the problem if we have the more parameters than the samples. So next is the uses of a ridge regression. The first is the when we have the independent variables which are having the high collinearity, that means what? The problem of multicollinearity between them. So at that time the general linear regression or the polynomial regression will fail. So to solve this type of problem, for the high collinearity type problem, we can use the ridge regression. Okay, and the second use is what? If we have the more parameters than the samples, so in that case we can use the ridge regression. Okay, and the limitations is what? First limitation of ridge regression is not helps in the feature selection. Sorry. Okay, not helps in the feature selection. So so it decreases the complexity of a model but does not reduce the number of independent variables. So it never leads to the coefficient being 0, rather only the minimizes it. Hence, this technique is not good for the feature selection. Okay, and the second limitation is what the model interpretability. So in that, so it is the disadvantages of this model interpretability. Okay, so it will shrink the coefficient for the least important predictors very close to the zero, but it will never make them exactly zero. So in other words, the final model will include all the independent variables are called as a predictors. Okay, so this is the model interpretability. Okay, the second type is a lasso regression. So here in the lasso regression, it stands for the least absolute and the selection operator. It is mainly similar to the Ridge regression except that the penalty term contains only the absolute weight instead of a square of a weight. So it takes the absolute values, hence it can shrink the slope to 0. Whereas in the Ridge regression it can shrink only it near to 0. But in the lasso regression it shrinks to the 0. So it is also called as the L1 regularization. The equation for cost function for lasso is what? Like this. Okay. Bj square, but here we have the vector, okay, or magnitude, sorry, magnitude of bj square. So some of the features in these techniques are completely neglected for the model evaluation. So hence this lasso regression can help us to reduce the overfitting in the model as well as in the feature selection. Okay, in the Ridge regression there is a limitation. So Ridge regression is not suitable for the feature selection, but in the lasso regression we can use the feature selection also. Next is the limitations of lasso regressions. क्या है? The problem with some type of data set. Types of data set. So if the number of predictors is greater than the number of data points, then the lasso will pick at most n number of predictors as a non-zero. Okay, even if all the predictors are the relevant. And the next limitation is what? The multi-collinearity problem. So if there are two or more highly collinear variables, then the lasso regression selects one of them randomly, which is not good for the interpretation of our model. Okay, so this is the multi-collinearity problem. Next is the difference between Ridge and lasso regression. Ridge regression is mostly used to reduce the overfitting in the model, and it includes all the features present in the model. It reduces the complexity of the model by shrinking the coefficient. And in the lasso regression, it helps to reduce the overfitting in the model as well as the feature selection. Okay. The second difference is Ridge regression never sets the value of coefficient to absolute zero, but lasso regression tends to make coefficient to the absolute zero. Okay, but in the Ridge regression there is a near to zero, not exactly zero. But in the lasso regression it tends to zero. So next point is the for Ridge regression the total sum of square of coefficient is less than or equal to s. Okay. So S is what the constant which exists for a value of a shrinkage factor lambda. And in the lasso equation, the total sum of modulus of the coefficient. Okay, see here the total sum of a square of coefficient, total sum of a square of a coefficient, and here the total sum of magnitude square. Total sum of a modulus of a coefficient is less than or equal to 0. Okay, so this is the difference between Ridge and lasso. S is what the constant which exists for each value of a shrinkage factor lambda. And the last difference is the ridge regression is described by b1 square plus b2 square is less than equal to s. And in the lasso regression equation कैसा होगा इसका modulus of b1 plus modulus of b2. Okay, coefficient of sum of modulus of coefficient is less than equal to s. Okay, so this is the difference between ridge regression and lasso regression. Thank you.